Vision Visual Demo. Deep learning is making waves in computer vision, enabling computers to understand visual information much like humans do. One fascinating example is the use of convolutional neural networks, CNNs, to identify handwritten digits. CNNs are neural networks that simulate how our eyes perceive images. Starting with convolutional layers that use filters, they capture critical features such as edges and textures. These features go through some activation functions to handle complexity and then are bundled for information reduction, preserving essential details. Through this training process, the network improves its ability to discriminate between handwritten digits. This tool helps us understand how image recognition works. Let's explore it. Here we have image samples for the digits 0 and 1. Each digit or class has 10 samples. All these image samples are grayscale with a resolution of 28 by 28 pixels. Next, we define the convolutional neural network or CNN model with 5 layers. The first layer after the input is a 2D convolution. Then we have max pooling 2D, followed by another pair of 2D convolution and max pooling 2D, and finally an output layer as a dense layer. The dense layer is a regular neural network layer that perceives inputs from the previous layers, applies weights, and uses an activation function to generate the output. The special 2D convolution and max pooling 2D layers will be explained in later sections. For now, just think of the 2D convolution layer as an image filter that detects features such as edges, corners, and textures, and the max pooling 2D layer reduces the image size by picking out the most important blocks. These layers have parameters like kernel size, filters, strides, activation, kernel initializer, and pool size. The regular dense layer has this unit's parameter in addition to activation and kernel initializer. Next, we have the model compiler configuration in terms of optimizer, loss function, and metrics. Under that, we have a training section where we define the max epochs. We can select any of these values. Now, when we run the system and wait for all the epochs to complete, we can start predicting the new image samples. As we can see, the loss value is quite low and acceptable. Let's do some predictions. For this input image, we press the predict button and see the result as digit class 0 with a probability of 0.966, and for digit 1, the probability is 0.034. The result is quite good considering the number of input images and the number of epochs. Let's choose an image for digit 1. So I'll select this example and I'll click the predict button. Note that the probability for this image is 0 has the probability of 0.032, and the probability that this image is 1 is 0.968. Again, the results are quite good in terms of accuracy. This covers how this tool can be used to understand how deep learning teaches computers how to recognize images. Please feel free to play with the tool by choosing different values for max epochs and predicting different test images.